Hi, the previous video we discussed about the two TDS relationship, and it seems to be very abstract, and what can we use it for? So here is the first application we can use TDS for. Remember one of the TDS relationship is ds equals du over t plus pdv over t. Okay, so this is if it's for solid and a liquid. If it's for solid and liquid, which means they are not compressible, right? They are incompressible. If it's incompressible, what do you think the dV will be equal to? Which means their volume stays constant, right? And dV will equal to 0. Then, this TDS relationship can be simplified for solid and liquid. This will be equal to 0. Then what do we have? We'll have ds equal to du over t. And then how do we calculate du for solid and liquid? So, how do you find du for solid and a liquid? Because we have done finding du for ideal gas. We talk about du is equal to CV or CP, CV over dt, right? If it's dH, that's going to be equal to CP dt, but this is for ideal gas. However, for solid and liquid, CV and CP, it's the same. So in that situation, to answer that, our du for solid and liquid is equal to C dt. Okay, so knowing that, we can continue to look at this problem. Our ds for solid and liquid is equal to du will be C dt over t. And our goal is to find entropy change, so delta S. So we're going to integrate. Delta S is going to be integration of C dt over t. From state 1 to state 2. Let's continue. So S2 minus S1, which is our entropy change, that's going to be equal to, and here if we assume C here is a constant. So if we take C out, that would be, we can use C at this average temperature. Then we have a natural log. Well, when we integrate 1 over t, basically it's natural log of t, and put our limit, so it will be t2 over t1. Now we have a formula for entropy change. Entropy change for solid and liquid is equal to C natural log t2 over t1. That will be the equation for liquid and solid. So look at the expression, the assumption we made. It's incompressible, so this term equal to 0. And here we learned for solid and liquid, du is equal to C dt. Because solid and liquid, they are not compressible, so CV and CP here it's the same. And knowing that, we got expression to find entropy change for solid and liquid. Okay. So that would be the end of this concept, and I'll see you the next time. Bye.